In a future section, we looked into calculating this future value from the present value in the compound interest factor. Using that formula, the future value is equal to the present value times that compound interest factor. In this section, we want to go the other direction. We want to know the present value required to achieve a desired future value given the parameters of that compound interest. So we're working this formula the opposite direction. We're solving for the present value. Some basic algebra tells us we're going to divide by that compound interest factor. That'll give us that the present value is equal to the future value divided by our compound interest factor. So let's take a peek now at some examples. These are going to be similar, very similar to the examples we used in the future value video. But let's find the present value required to have $8,000 after 5 years at 5.9% compounded quarterly. So again, we're looking for that dollar amount that we have to start with. So that's the present value that we're looking to find. In order to achieve a desired future value of $8,000, a rate 5.9%, so 0.059, N compounded quarterly, so N equals 4 times a year. And of course, T, our time, is 5 years. So our formula becomes the present value is equal to that desired future value of $8,000 divided by our compound interest factor, open parentheses, 1 plus 0.059 divided by 4, that's 4 times a year for N, to the power of 4 times 5. Now, as I mentioned in the future value calculations, 4 times 5 is 20, and if I combine those before I type it in the calculator, it makes it a little bit simpler to enter. So it's $8,000 divided by my parentheses, 1 plus 0.059 divided by 4, close our parentheses, to the power of 20. So we get 59, 69, 10. So this is telling us is in order to have $8,000 after 5 years at that 5.9% interest compounded quarterly, we must start with $5,969.10. Sam wants to have $2,500 in 15 years. How much should Sam invest now? At 8.3% compounded monthly. So we're asking how much Sam should invest now. So that implies we're asking for a present value. So the future value is that $2,500. Our rate, 8.3% or 0.083. N here, compounded monthly, tells us N is 12. Enter time, T, 15 years. So to make our formula, we're looking for that for that present value required. We're taking our future value of 2,500 divided by, or open parentheses, 1 plus 0.083 divided by 12, close parentheses, to the power of 12 times 15. Now again, I would typically multiply this out, get 180, but we can enter it like that if we wanted to. So either way, our 2,500 divided by parentheses 1 plus 0.083 divided by 12. Close our parentheses, and then to the power of, I could just type in 180, which is what I would normally do, or I can put in the parentheses 12 times 15 and close those parentheses. Hit equals $722.94. So in order for Sam to have $2,500 after 15 years, Sam needs to start with $722.94 in that 8.3% compounded monthly. One last example here. Find the present value if $4,000 is desired after 8 months at 3.1% compounded monthly. So once again, we're looking for present value. We have future value of $4,000. We have our rate, 3.1%, which of course is a decimal, is 0.031. N, compounded monthly, so N is 12. And our time, T, is 8 months. But remember, as before, we've always said our time always has to be in years, so that's 8/12 of a year. So that present value is equal to that future value of $4,000 divided by 1 plus 0.031 divided by 12 to the power of N is 12 and T is 8/12 of a year. So in the calculator, we're going to put in 4,000 divided by parentheses 1 plus 0.031 divided by 12. Close our parentheses to the power of, and we'll open parentheses in the power, 12 times 8 divided by 12. Close that parentheses and hit enter. Something went wrong on me there. I believe I want to double check my entry here. Yes, I punched that in one more time. My 2 didn't register on my 12. 4,000 divided by parentheses 1 plus 0.031 divided by 12. Close parentheses to the power of, open parentheses, 12 times 8 divided by 12. That looks better. So we get $3,918.29. So what they're saying is in order to have $4,000 after 8 months at 3.1% compounded monthly, you must start with $3,918.29. So that's the concept of finding the present value, the value needed at the beginning of an investment to achieve a desired future value or ending value for that investment.